Good morning, mathematicians. It is Wednesday of week 34, and we're getting started here with modeling. Multiplying fractions, I have written 3 and a third over here. I have written 5 and 2/5 over here. And notice what I've done is begun the multiplication process. 3 times 5 is 15. 1/3 times 5 wholes is 5/3. 3 times 2 over 5 is going to be 6 over 5, 6/5. And then if I have 1/3 times 2/5, I'm going to have 1 times 2 is 2. And I'm going to have 3 times 5 is 15. So the next thing that we need to do is combine these values. So I'm going to write them here. I have 15 plus 6/5 plus 5/3 plus 2/15, right? Well, the first thing I need to do is convert these fractions to an equivalent value, but that has a denominator of 15. This one is already there. It's already 2/15. Now I need to ask myself, if I have 6/5 here, what would that be over 15? Well, I would have to take this 5 and multiply it by 3 to get to 15. So I must do the same thing here and multiply this 6 by 3 as well. That way I'm multiplying the numerator by 3 and the denominator by 3. That's really a fraction of 1, 3/3. I'm not changing the value. I am simply creating an equivalent fraction. Let's do the same thing here. 3 times what gives us 15? Well, that's 3 times 5 is 15. So my numerator must be 5 times 5, which is 25. So now I can say, okay, I still have this whole number of 15, but now I'm going to add all of these together. 18 plus 2 is 20. 20 plus 25 is 45/15. All right. Well, I'm still going to have that 15, but now I'm going to ask myself, how many times can 5 go into 15? I know I can get exactly 3 groups from that. So now, finally, after all this work, mathematicians, we have found our answer of 18 wholes. And I'm going to rewrite that right there. Okay, if you need to pause and rewatch that, certainly you can do that. There was a lot of problem solving here to get to this one overall answer. Okay, let's take a look at this irregular prism. I'm going to count how many cubes will be on the bottom layer, and I'm going to do that by thinking about it like an array. I have 1, 2, 3, 4. I have 1, 2, 3. So my bottom layer is going to be 12 cubic inches. Let's do the same thing for the top layer. We have 1, 2, 3. We have 1, 2. So I'm going to label those here. We had 3 this way. We had 2 this way. So I know that 3 times 2 is 6. I have 6 cubic inches. So what I must do is add these together to find out that overall it's going to be 18 cubic inches. And I can read that up top where it already says cubic inches. Now, this one I had to stop and think about for just a moment. Let's do the same thing now. A fish tank measures 30 centimeters long, 20 centimeters wide, 10 centimeters high. At first, the water level is only 8 centimeters high. You can add, and then let's talk about what we do next. So first, let's start with this overall first sentence to see truly what the capacity is, or the volume of the fish tank. The fish tank has a volume, a maximum, that it can be filled with 30 times 20 times 10. Of course, I used the volume formula, and I should have written that first, because really to use a formula, you got to write it out first, then exchange it for those dimensions. I know that 30 times 20 times 10 is going to give me a maximum capacity of 600 cubic centimeters. And I'm going to write right here that really remember this is the max that it can be filled to. Now, I have a fish tank at home, and it is rarely filled to the very top. And certainly what it tells us in this next sentence is that it was not filled to the 10 centimeter line. It was actually to the 8. So let's find out what it was when it was at 30. times 20 times 8. Notice 8 instead of 10. When it was filled to this capacity, and when you do that multiplying, you're going to find that it was actually filled to this 4,800 cubic centimeters. This is what it was filled to when it was 8 centimeters high. Okay. Now, let's go and read the next part. You add an extra 2,000 cubic centimeters of water, making it overflow. How much water spills out of the tank? Well, if I was at 4,800 and I added 2,000 cubic centimeters of water, I am now at, I tried to be at 6,800 cubic centimeters. Now that's too much water, but it's too much water by how much? Remember, the max was 600, so this is exactly 800 cubic centimeters too much. Boys and girls, that is how we find our answer to that scenario. Okay? Let's go down and let's take a look at this next one. And I'm going to use a little steno pad to make sure that I can show you how you really can use the distributive property here to multiply this. Because I'm going to make my 4 multiply itself by the 1. And then I'm going to make my 4 multiply itself by the 1/3, right? Now, I don't always write this out like this because oftentimes we do this more efficiently. But for the sake of showing you how this is working, I want you to notice what we're doing. We're multiplying the 1 or the 4 times the 1, and then we're multiplying the 4 times the 1/3, right? That is where. And notice here, I've just written the 4 as a fraction because certainly we notice we can just multiply the numerators, multiply the denominators. And in this way, boys and girls, we're going to get 4, and we're going to add 4/3. Now, traditionally, mixed numbers have a whole number part and a proper fraction part. This is improper. So let's go ahead and convert that first. I know that 4/3 is equal to 1 and 1/3. So really my answer here is going to be 5 and 1/3. Now, once again, boys and girls, you don't have to write all of that out every time. I wanted to do that to help us kind of see the thinking that goes on in our brain when we are multiplying like that. And certainly that's the first one. Let's go ahead and think about this next one. I have got 5, and I'm going to multiply it by 7/3. Just like we noticed here, we're really multiplying the 5 by the numerator because this is really 5 over 1, right? So we have 5 times 7, which equals 35, and our denominator is 3. 8 and 2 turn into proper fraction into mixed number. We say, well, how many times can 3 go into 35? It can go in 11 times. That would use up 33 of my 35, and there's 2 left over, and our denominator stays the same. So my answer is 11 and 2/3. Lots of thinking in today's work. Let's go ahead and look at our next one. Our next one is 5 and 13/100, and we're going to multiply that by 3. Let's do this similar thinking, but let's see if we can talk about it and be more efficient and not write it all out. Here I have 3, and I'm going to multiply that by the 5, so that is 15. Now I'm going to multiply the 3 by the 13/100, and I'll remember the pattern that we've seen. We can just take our whole number and multiply it by our numerator. So we're going to have 36/100. Now, this is a really cool fraction. I can keep my answer like this for sure, but just for the sake of thinking about how smart we are at this point in math, everything we've learned, think about if I were going to convert this to a decimal, 36/100 would also be like this, wouldn't it? Don't I read this as 36/100? So that's kind of a cool one, kind of a special one, because it's really easy to convert into a decimal. But certainly for the sake of this question, we're just going to write that answer right there. Whew, man, my math brain is definitely working hard for today. And we are thinking now about this irregular shape. I'm going to call this prism A. I'm going to call this prism B. For prism A, we're going to do volume equals length times width times height because we're certainly not counting cubes here. So I know that my length is 7. I know that my width is 3. And I know the height is right here, but it's not labeled. So I'm going to have to use these measurements to figure out the height of this. The entire height of the whole shape is 8, but this part of the height is 5. So I have a missing part here. What plus 5 equals 8? The height of this is 3. So I'm going to multiply by 3. There's my volume formula that I shall use. Well, let's go ahead and combine this to be 7 times 9, because I know that that is 63, and it's 63 cubic centimeters. That is the volume specifically of prism A. Now let's do the same thing for prism B. For prism B, I'm also going to use volume equals length times width times height. So let's take a look here. I know that the length is 3, and look, the width is also 3. I see it right here and right here. So that's going to be 3 times 3. Now this height has to be bigger than this, right? And in fact, it's 5 bigger than that. That's how we figured our height for the other side. The height here is 8. So I know that I'm going to do 9 times 8, right? Well, 9 times 8 is 72, and it is 72 cubic centimeters. What do I do to the volume of prism A and the volume of prism B? I have to add them. Don't forget, so important. What we do to irregular prisms is we add. So we have 63. We have 72. 3 plus 2 is 5. 6 plus 7 is 13. So in all, our answer is 135 what? It's going to be 135 centimeters cubed. And certainly we want to make sure we are writing our answers with those cubic units since our measurement is in cubes. Finally, that finishes out our Wednesday column.